Alright, so we're going to get into exponent properties. So we're going to start with, and actually this is the first 4 sections of chapter 7. We're going to start with, we need to remember what an exponent is. So an exponent represents repeated multiplication. So if I have 2 times 2 times 2 times 2 times 2, then this would be equal to 2 to the, 1, 2, 3, 4, 5, 6, right? So repeated multiplication becomes an exponent. Other things to keep in mind, we have specific names. So the whole thing is considered a power. Our A here is our base. It is what holds up, kind of like in cheerleading. The base holds up the flyer, and then our flyer in this case is our exponent. But the whole thing, the base with the exponent, is considered a power. So when we talk about powers, we're talking about that whole representation. All right, so getting into our first set of properties, 0 and negative exponent. So our properties for every non-zero, and I'm going to write this on this page, and you just need to remember that this goes for all of them. For every non-zero, A, B, in this case it's going to be A to the 0, A being any number, any real number, A to the 0 equals 1. So anything to the 0 power equals 1. And if you're about ready to say, but Mrs. Cartwright, what about 0 to the 0? Okay, well, let's talk that out real quick. We may want to say that 0 to the 0 is 1, but then if we say we have, say, 0 to the first power, that's 0, and 0 to the second power equals 0, and 0 to the third power equals 0, and technically still 0 to the 0 power equals 0. So we cannot be both 0 and 1. Technically impossible. So 0 to the 0 power is undefined. Which is why all of these say for every non-zero A. So we're talking about any number that's not 0. But for those of you who are wanting to try to say, but what if? What is 0 to the 0 power? Beating you to the punch. Alright, negative exponent property. For every non-zero A, well, I guess integer A, A to the negative n will be equal to 1 over A to the n. Or 1 over A to the negative n is equal to A to the n. So basically negative exponents, we move where it is. If it's in the numerator, it gets moved to the denominator. If it's in the denominator, we move it up to the numerator. That's negative exponents. So let's practice this a little bit. Example 1, what is the simplified form of each? So we're going to start with this one. This is a negative exponent. It right now is in the numerator, right? We're over 1. So I'm going to then put it in the denominator and make my exponent positive. So I heard another teacher explain it this way. Say you and your siblings get in a fight, right, upstairs. And so you get sent to your separate locations downstairs and you become good. You've been removed from the situation, so you become good. So that's why we go from being a negative exponent to a positive exponent. And because we moved. And then if it says, right now it just says simplified. This would be simplified. If it says evaluate, then the evaluated form would be 1 over 81. That's when we evaluate. So you got to be careful of what it's asking for. Simplified would be to leave it in exponential. Evaluate means go ahead and figure out the answer. Evaluate all the way through. All right, this is a 0 power, and anything to the 0 power is 1. It could be 1,264 to the 0 power still equals 1. It's that simple. All right, on this one, I'm looking, nothing here, nothing here. Oh, I've got that negative exponent. So that means, now, the negative exponent is only with that base b. That is the power that has the negative exponent. So my 5a cubed will stay in the numerator. The only thing moving is my b squared. It was the one that was being bad upstairs and is being sent downstairs to its room in the basement and is becoming better. We can only hope, right? All right, and then here we have a negative exponent, another negative exponent. This one's in the denominator, which means we would move it to the numerator, since it is the only thing that will just make our answer x to the 5th. And that is how negative and 0 exponents work. So now, how do we evaluate if it gives us variables? So my suggestion is we take the original, and if I can do anything to this first to simplify the expression, plugging in will be easier later. You're going to make fewer mistakes. So, because I have this negative exponent, I'm going to move that to the bottom. And again, that negative is only with the t. So the 3s cubed is going to stay on top. The only thing moving to the bottom is our t squared. So now having this, I'm now going to plug in for s and t. So we're going to have 3 times 2 cubed over negative 3 squared. From here, it's just using PEMDAS. So my parentheses are only not really grouping anything, so now I'm going to go on to exponents. So I'll have 3 times 2 cubed is 8 over negative 3 squared is 9. Remember, if it's an even exponent, then any negative becomes positive. Any even exponent will give you a positive answer. If it's an odd exponent, then you look at the sign of the number inside, or that you're squaring or cubing. Okay, from here, I'm going to look at this. We're at a point we should be able to simplify from here. So I know that 3 goes into 9, so I'm left with 1 and 3, because 3 goes into 9 3 times. 1 times 8 is 8, and we were left with just 3 on the bottom. And so that is our evaluated form. And that is it about negative and 0 exponents. So in our next video, we'll be talking about our multiplication properties.